Well, hello, everyone, and welcome to the webinar, Finding Common Ground, Bringing Methods and Analysis into Context with Dr. Gregory Privitera. My name is Sherry Countryman. I'm the Senior Marketing Manager for Psychology at Sage Publications, and I will be your moderator today. Before we begin, I'd like to ask you to reply to a few polling questions that we've set up. The first one is, what area do you feel is your strength? Please select methods, stats, or both. We'll give you about 30 seconds to reply. All right, just a few more seconds here. Okay, let's go ahead and close that poll. See what you all said. It looks like a lot of you feel that research methods is your primary strength. Thank you. We've got one more polling question for you. How often do you discuss statistics in your research methods classes? Go ahead and take a bit of time here to reply. Be interested to see your results. All right, let's go ahead and close that poll. Looks like many of you do discuss stats in your methods classes quite often. So thank you for your responses. It's always helpful for our presenter to get to know the audience a little bit better at the beginning of the presentation. And speaking of our presenter, I'm very thrilled to be able to introduce him to you today. We are talking about, of course, Gregory Privitera. He is an associate professor of psychology at St. Bonaventure University. Dr. Privitera received his PhD in behavioral neuroscience at the State University of New York at Buffalo. He went on to complete postdoctoral research at Arizona State University before beginning his tenure at St. Bonaventure, where he recently received the school's highest teaching honor, the Professional Excellence in Teaching Award. The first edition of his text, Research Methods in the Behavioral Sciences, was the recipient of Most Promising New Textbook from the Text and Academic Authors Association. Quite a high honor. Dr. Privitera is the author of Statistics for the Behavioral Sciences, second edition, Essential Statistics for the Behavioral Sciences, and Getting into Graduate School. He has written extensively about the psychology of eating, in addition to authoring over 24 peer-reviewed scientific articles aimed at advancing our understanding of health and promoting the intake of healthier diets for children and adults. Dr. Privitera oversees a variety of undergraduate student research projects at St. Bonaventure, where over 24 students, many of whom are now earning graduate degrees at various institutions, have co-authored research in his laboratories. For his research work, Dr. Privitera was recognized by St. Bonaventure as Advisor of the Year in 2013 and was awarded an Early Career Psychologist Award by the American Psychological Association in 2015. In addition to his teaching, research, and advisement, Dr. Privitera is a veteran of the U.S. Marine Corps and is married with two terrific children, a daughter, Grace, and a son, Aiden. This one-hour webinar will be recorded and archived for future viewing, and we will be sending out a link to view it and to access the slides to all the registrants in the coming weeks. If any of you have any problems with the audio or viewing mode during the webinar, please use the Q&A box at the right of your screen, and one of our helpful team members will get back to you as soon as possible. At the end of the webinar, we will have some time for Q&A from the attendees. So please also use the Q&A box to ask any questions to our terrific speaker throughout the webinar. Please also take note of the webinar hashtag SageTalks, and feel free to ask questions or leave comments there. In terms of introducing the webinar today, just wanted to revisit our presenters' goals for you. Really, this webinar is designed to help facilitate your instruction and enhance your teaching. Dr. Privitera is so focused on students and their success that we really wanted to pull together a presentation that helps students see the purpose of engaging in research methods and help them see behavior as a science as well. So without further ado, I'll now pass the mic over to Greg Privitera.
Thank you so much, Sherry. I really, really appreciate it. Sherry, by the way, is incredible and one of the hardest working women I've ever met. So thank you so much. It's great. Thank you for coming. And I'm used to doing these face-to-face. So speaking to a screen is a bit daunting for me. I think it's always best to really look at the behavior as a science, because the outcomes often drive the instruction. For a lot of the work that I do as a professor, and I'll end with this as well, it's really about trying to empower students. And you're not going to write learning objectives that I'm going to empower you by the end of this semester, by the end of this term. But it's something that's very important. I remember myself as a student, and maybe you had a similar experience, whether as a student or as a faculty member. When I took a statistics course, and then I took my research methods course, they felt disjointed. I didn't see the overlap. I didn't see how they're related. And even though I understood the material very readily and I scored A's in both of those classes, I felt unprepared for being a research lab assistant. And I find that disappointing, I would imagine, since I think a big goal should be to have them prepared for that type of work. And I understand we want these students to be critical consumers of general knowledge. But I think behavior as a science is a really, really good place to start. And for me, I felt like I wasn't getting the whole story. And to sort of illustrate this, I like to sort of come back to this idea of thinking of science as a larger construct than just statistics or analysis, just methods. The fear, and it's neat being able to read the polls, the majority feel their strength is research methods of the audience that's here, which is fantastic. And it's about 50-50, I'm overgeneralizing, but about 50-50 that stats is incorporated readily in the classroom. And I think often the fear is, well, you know, I don't want to overload students with this information about statistics when I'm trying to teach them methods. But in many ways, you can't have one without the other. And there's a lot of common ground between them. So it's not necessarily true that you need to add anything necessarily to what you're teaching them. If anything, you might be able to use concepts from one to help make better sense of the other. I simplify science as having two parts in general. You have the methods or the rules involved, and you have the analysis, which is the data. I had a colleague once say, we were talking about how we assess the quality of our program, and we were looking for data, and he said, well, some data are better than no data. Let's just go find some. And that's really not a very good statement to make. We don't know the origin of the data. We don't know where it came from, who was sampled, how the data, has the data even been maybe mined or changed in some way. In other words, simply having data in front of you is not science. there needs to be rules or methodologies followed that are going to dictate the types of decisions that we can make. I always like to go back to the game. My daughter, Grace, who's 8 years old and absolutely the center of my little world with Aiden, but Grace has defeated me in a game called Chutes and Ladders 100% of the time. I have never been able to defeat her. Okay. Now, Chutes and Ladders, if you don't know it, is just a game where there's 100 squares on the board. Then you move along. If you get to the bottom of a ladder, you get to climb it, skip spots. If you get to the top of a chute, then or a slide, then you have to slide down it and you lose spots. Well, for my daughter, she says that she shouldn't have to slide down the slides. She should be allowed to climb everything. So, of course, while I'm sliding down slides all day long, she's climbing everything, and she has defeated me 100% of the time. And the conclusion could be that my daughter is the greatest Chutes and Ladders player of all time, given that she's undefeated. But of course, if we go back to the methods, to the rules, we find that the rules aren't being followed in a way that would justify that decision. But don't tell her. She thinks that she's the greatest Chutes and Ladders player of all time. We'll keep it at that. The idea being that there are rules that dictate, for scientific, we're talking about experimental, non-experimental, quasi-experimental, that dictate the level or types of conclusions you can draw. But on the other end of that, you engage in these methodologies. You follow the rules. You have this data. That's not the end of the story, and that's part of the loop that wasn't being closed when I was a student. I didn't understand how this process finishes because often we're hesitant to overload students with this analysis end. But I had an example. I had a colleague once. We were looking to improve enrollments in the psychology department, and so one of the administrators says, "Well, we've hired a company, and they're going to help us, and we are looking for an increase in 3 students this year from last year. And if we can get to 3 students, we're going to consider that a successful, that this was a success, the changes that we made." And so that would be the decision or the outcome. The problem with that is, and one of my very astute colleagues raised his hand, and he said, well, the standard deviation for students in any given year is 4. So you're basically looking for a signal within the noise. So when you have these data and you say, oh, wow, look, there's an increase of 3 students in psychology, well, this must have worked. That's not necessarily true. There needs to be meaningful analysis that goes with that. And often the language between the two overlap substantially. But you need them both to get, even in qualitative, and I understand that's not going to be numeric data. There's books on how you analyze qualitative data, which is probably much more difficult than analyzing quantitative data that you just plug into an SPSS or some other statistical program, and bam, it'll just give you results left and right. And I think a good way to sort of illustrate this, because here you're looking at, you go into a statistics class and they teach you all about the data. You go into a research methods class and you learn all about the rules. But how they come together would be meaningful. And I'm going to give you 2 key examples where I feel that you really can sort of see this. This is an example, and if any of you have a background in cognitive psychology, you may have come across this. I'm going to read this to you, and then you'll see the idea. Okay, so here's this phrase, and it's something taken from Bransford and Johnson in 1972. If the balloons popped, the sound wouldn't be able to carry, since then everything would be too far away from the correct floor. A closed window would also prevent the sound from carrying, since most buildings tend to be well insulated. Since the whole operation depends on the steady flow of electricity, a break in the middle of the wire would also cause problems. Of course, the fellow could shout, but the human voice is not loud enough to carry that far. An additional problem is that the string could break on the instrument. Then there would be no accompaniment to the message. It is clear that the best situation would involve less distance. Then there would be fewer problems. With face-to-face contact, the least number of things could go wrong. Now, if you're like me or anyone else with basic understanding of English, this sounds like gibberish. Okay? It's one idea to the next, and it doesn't make any sense. All you're getting is the story. But now I show you this. And take a moment to read through this passage again and use the image as a way to gauge your understanding of the message. And even by the time you get halfway through, you start to smile. At least I did. And I realized, wow, the whole thing does actually make sense if I have the picture to view as well. The way I always felt in a statistics or in a research methods class was that they were giving me this phrase, this little passage, and they weren't showing me the image to go with it. So I'm getting research methods or I'm getting statistics, but they're not ever closing that loop to let me see the whole thing. So you can study that picture all you want. You can study that passage all you want. Until you bring the two together, you don't see the full story. And that's the way I felt. I feel like it's a good analogy to bring out this way that I felt about statistics and research methods was, how do I start to look at this overlap? How do I maybe, because the biggest constraint for all of us, and I appreciate this, I have the same constraint as any other faculty member, and that is time. There's only a number of statistics, research methods. There is a lot of content to go into those courses. If there's one thing we're not lacking, it's plenty of things to talk about in any given class. So time, the ability to be able to effectively do this, the consideration needs to be also, how do I do this without really adding time in the classroom to do it? And so here are ways that I've made an effort to really bring them together, not in a way that adds things for them to learn, students, but actually makes more sense of it. You can see, control and causality, individual differences, variability, and error. Those are going to be the examples that I'll use today, just as examples of how this is actually delivered. But there's other concepts. Sampling within a statistical context. You typically talk about the types of sampling with regard to sampling distributions. Within a research methods class, you talk about sampling from the more practical sense of how do we get participants in a study. Scales of measurement, hypothesis development, power, effect size, sample size. All of these are relatively important, and they're going to be spoken about differently depending on which of those two classrooms. And what I want to do is just sort of illustrate two of these examples. And one is variability, error, and individual differences. And that's the one I'll start with. Because error tends to be a statistics term. You use that term in statistics, and it is very likely that you may not at all use that term in a research methods class. But in many ways, individual differences is the synonym for error. It's the methodology end of error. And so I will go into a classroom, and I will say, and I will point to a handful of students and say, you know what, you're a very unique person. You're a unique individual. I really like your unique qualities. And when I run you in a study, when I run a study and you're a participant in that study, I can measure those individual differences. I can measure those idiosyncratic aspects of you that make you unique. And when I was told this as a student, it made no sense to me. And it made no sense to me even after I got an A on the exam on that course. And so what I did was I tried to come up with a way to illustrate this in a meaningful way. So I came up with two data sets. And here you can see, and for me, I find it very important anytime you're presenting data and graphs to students to put them together. There is a huge disconnect for students when they look at data, and then if you switch to a new screen or erase the data and draw a graph of it, they lose track of the fact that that data corresponds to the graph. So it's always nice to show it together so that they can view it at the same time. But you can see that for example A and for example B, both of these are what we would call a three-point effect. Treatment B, the mean is 5, and treatment A, the mean is 2. And the same is true in B. So it's actually coincidentally this three-point effect, like the example I gave earlier, the signal within the noise. Just because there's a 3-point difference between these two treatments doesn't mean that they're necessarily different. There's variability. So I said, okay, well, let's graph it, and we're going to play a little game. I'm going to keep, and I would have a pointer. I'm going to keep bringing my pointer across, and you tell me when I'm all done with a group. So, and I apologize, bars aren't as distinct as they could be. The light blue bars are group A. The darker group bars are B. And so I will bring this, and I hope that you can see my cursor, and I'll bring it over, and then they'll tell me to stop. And so you can see, here we go, we'll draw a line, and there I have a line, and I ask, okay, now to the left of this line, is there anyone in treatment B infringing on treatment A's space? So I've marked my territory in treatment A right here. Is anyone in treatment B on my side? And the answer is no. And I said, so what you're telling me is I can draw a line and split these data points up by groups. And the way that I phrase it is the groups are different. There is a clear delineation between scores in treatment A and treatment B, and it's never this clean, but it's easier to use nice and clean examples. The idea being that the less overlap, no overlap preferably, makes it more and more obvious or likely that it's going to be the groups that are different. There's very little other variability going on. In treatment B, though, there's a lot of people being different. There's a lot of individuality going on. And so what I'll say, let's play the same game, follow the same rules. I'm going to keep going and tell me when to stop, and then we stop about here. So I draw my line and I say, is there anyone in treatment B infringing on my territory? And in this case, the answer is yeah. There are 2 people who scored a 4 and 1 person who scored a 1. So now 3 out of the 5 participants in treatment B are behaving as if they're in treatment A. Here it just looks like people are different. This 3-point effect is just some sort of effect that's really superfluous. It's not real. And then we'll actually analyze it. And there's no need to do that in every case. I like doing it. And so I'll say, okay, let's do a nice simple 2 independent sample t-test. And when we do it for treatment A, it comes out significant. When we do it for treatment B, it comes out not significant. So you have 2 groups. In one, you can clearly separate the groups by a straight line, and there you can see groups are different. And in the other, you can see that there's a lot of overlap. Yes, the means overall are showing a mean of 5 and a mean of 2, but there's a lot of individual differences going on here. That's going to be measured with error. So when we do the analysis, they can see the denominator is much larger when we analyze group B than group A. That's how we're measuring this individuality of people, not in a literal sense, but in a statistical sense. So there's this random variation, and so they can begin to see where these individual differences come into play, this thing that we're controlling for methodologically if we're running an experiment, true experiment, but then also accounting for statistically by evaluating how much overlap is there. Can I clearly split these groups up by group, or is there a lot of overlap and it just seems like the effect might be superfluous? So this is one of the examples that I give to try to start to overlap the language in a way where you can look at data, you can talk about individual differences in a research methods class, but then also to try to make sense of it more so on the analysis end, talk about it in terms of variability and error, talk about it in terms of the fact that we're going to measure this in some meaningful way. Which brings then to the cause and effect and control. So often we talk about methodological control, and I teach that, look, the experiment is great if you desire to make conclusions about cause and effect, but not all questions demand that, and not all research hypotheses need that as a decision. But then also you just have situational factors, like a lot of education is quasi-experimental, not because it's in any way a weak science, it's because of the nature of the designs. They're in classrooms in real time. The ability to randomize students into different classes is just about logistically impossible. So they have methodological ways of getting at that, albeit without cause and effect decisions. But it's a nice way to talk about it in terms of control, because what you have is you have two different levels. So I'll talk about methodology. Well, with the between subjects experimental design, we use random assignment. Okay, so we randomly assign participants to each of the groups, which then we can assume individual differences are about the same. I always emphasize that's an assumption. And more than likely, there's still going to be random variation in scores between the different groups that you're observing. And for that, then, we use a statistical level of control called the test statistic. And when I teach the test statistics, particularly for the experiment, I usually focus on teaching them only with the experiment. And then I identify that you can use them with a quasi-experiment. For example, if you were to look at sex differences, male, female. Well, then in that case, you can use a between subjects design, but it's not experimental. Obviously, you're a man or you're a woman. I can't randomly assign that variable. And you can use the test statistic, but because you lack the methodological control, you can't use cause and effect conclusions. At the same level, if you establish methodological control and then measure the data, you have to analyze it statistically. As you saw with those two 3-point effect examples, one is a real effect and the other is not a real effect. It's superfluous. It's not real. And so what you need is that statistical level of control to make that decision, to get to the science. The science are the decisions that we make, and they're scientific decisions, quote unquote, because we followed the rules and we analyzed the data. Within subjects, then you would control for timing and order, and as we go to the next slide, you can see that here you have this closing of the loop, so to speak. You select a sample at random to the best that you can, and then you can create 2 or more groups by manipulating the levels of an independent variable. This, of course, is an example of a experiment. Now, at the next step, you can use random assignment to select participants, in which case then it's a between subjects design, or you're going to observe the same people repeatedly in each group, and so you control for order and time-related factors and observe the same participants in each group. Here you have methodological control. That's the purpose of this step, or these steps, is to establish that control. You then measure the dependent variable in each group, but that's not the end of the process. And so often in a research methods course, we stop there. We're worried that if we bring in the statistical evaluation at the end, it's going to become this hybrid course. When I hope, at least, that you've seen at least 2 examples where it would actually help bring greater sense to it. It's not adding significant time to the class. It's allowing you to be able to take the natural overlap in language and bring them together in a way that helps to make more sense of it. When I think about finding common ground, a lot of this comes from my faculty mentored research. I've worked with a lot of undergraduate students. 28 undergraduate students have published research with me in reasonably strong journals. Some of the work has been featured in the Wall Street Journal. 3 of our student research projects with undergrads were featured in the Wall Street Journal. We had a feature in Oprah's magazine, a feature in Time magazine just a month or 2 ago. So this research is impactful. This research is interesting, it's strong, and it's undergraduates doing it. And so for me, a very important aspect of this process of thinking about how to retool the classroom was to get students what I called lab ready. And that was, I want you to be able to feel confident. I don't want you to feel insecure. I don't want you to feel that even though you're an A student, you still don't feel that you can move into a laboratory and be an effective research assistant. And so I feel that closing the loop often in research methods classes would often follow a statistics course. It's much more effective to be able to close that loop for them there. Let them see every aspect of it. When they see the individual differences, they can see its overlap with error and how it corresponds. When they see this cause and effect and start to think about it from a methodological point of view, they then see that there's also a statistical level that needs to be incorporated in order for you to establish that. And when you start to put this all together, you may not find this in your learning objectives, but it can have a great impact on students, because by closing that loop, by helping students to see how research methods fits within the bigger picture of engaging in science, within the bigger picture of making decisions, such as whether or not this company that we hired is effectively actually increasing enrollments in psychology, for example. It can be a powerful thing, and I feel that for me it's been a reasonably successful in terms of getting students ready and seeing how excited they get when they realize that this isn't something that's beyond them. This is something that they can accomplish, and it's something that actually makes them feel like they're better thinkers, they're stronger thinkers, and that's something that's really, really powerful to me. And with that, I want to thank everyone for attending this webinar. I hope that some of the ideas, if one idea is something that appeals to you, that you see, that you can relate to parts of this, because I know that for many of you, for most of you, for all of you, you have as much experience, if not more experience in the classroom as the experiences that I've had, and I really look forward to your questions. I think that it'll be fun and engaging, and now I'd like to return it to the hardest working woman I think I know, Sherry. Thank you so much.
Well, Greg, thank you. I mean, that was just terrific. I love that cartoon that you shared, by the way. And I can truly say, while I was, listening to you and watching the slides, gosh, I wish I had had you as my teacher when I was in school. I might very well have become a psychology major. No kidding. I remember sitting in my my stats class and going through the whole semester thinking I knew what was going on, and then getting to the test and going, oh my God, am I in the right class taking this exam? So no, I just as an audience member here myself, really appreciate what you've put together, and know that it's just hopefully helps a lot of folks on the line today, and I certainly understand why your students appreciate you so much. So thank you so much. Now we're going to spend some time addressing some of the questions from our audience. And please, as a reminder, continue to send them into the question box that's on the right side of your screen, or you can use Twitter with the hashtag SageTalks. And then if we can't get to your question by the end of the hour, Greg has graciously agreed to address them. So we'll be sending out a follow-up blog post and email from Sage, and you'll be able to see not only his answers, but the slides from today's presentation, and then you can listen to the recordings and so forth. Okay, we'll start off now with one of our questions from the audience. And Greg, here's a question for you. Does it take substantial more time to incorporate analysis with research methods?
That's an excellent question. One of the ways to answer that question is to say it can, but it typically doesn't need to. When we look at the overlap, you can see that. But in terms of even, say, incorporating technologies, which is another aspect of how I try to accomplish this in the classroom, it is looking at it through two perspectives. One, incidental learning. For example, you saw the data together with the graph. Well, one of the easiest ways to do that is to, instead of using a PowerPoint or instead of using a chalkboard or a smartboard, literally just open up an Excel spreadsheet. Open it up with, you can have data preset, but Excel is so dynamic of a tool. You can hover over different data sets and watch the graphs literally change live, and you can start to look at that. You can run a lot of the simple analyses just right in there. You don't need to open up SPSS. A correlation, for example, is a really, really simple formula that you can plug in just to be able to see it, and the graphs for these correlations will automatically spit that out as well. in addition to your coefficient of determination and all the other statistical terms if you want to start getting that detailed. And the other aspect would be to start to think about if you had an SPSS spreadsheet, an SPSS data set, and you knew what data you were going to work with, and you went through the methodological rules, like, for example, that small data set with a mean of 2 and a mean of 5. Well, I already have those preset in SPSS. All I do is open those up. Now, it's always easier, and we get spoiled. We have statistics come before research methods, so I know that they have some background in statistics and feel comfortable being able to walk them through these steps again, which for many of them should be a reasonable review. But even if not, it's still good to at least have them see the screen, and you can walk them through using regular terminology, the meaning of the data. Certainly p-values or some meaningful way of describing the basis of a decision is discussed in most research methods book as a basic type of statistical criterion. And you can find those in the SIG boxes. It's incidental. You don't have to test it. It doesn't need to be something on a final exam or a quiz. But you can now quickly just produce those two output tables, and you can compare and say, look at that. That p-value is bigger than 0.05. So that means it's really likely this could have occurred by chance. Well, likely enough that we'll assume it did. And this one's less than 0.05. So we're going to conclude there is an effect. And then go back to the data and say, see, I told you we could divide these groups up by groups. It was really clean. We can be very confident that the groups are definitely different. Treatment A did something different to treatment B, whereas we're a little more confused about whether those treatments are having that same effect in the second example, even though they also have a 3-point effect. So in many ways, you can use it really to sort of bolster or enhance the conversation you have about these different types of data sets you work with, because you're certainly going to work with different sets of data in a methods class for the different types of designs that you introduce. So I guess it depends on the perspective. For me, I find it's pretty minimal the amount of time I necessarily am adding to the class to be able to introduce or expose students to these different types of things. I find that it largely actually enhances when you retool it, when you rethink it. It really makes it easier for me to make sense of this for students, and that's the feedback that I've received as well. All in large.
Great, thank you, Greg. We had a couple other questions too. Obviously, you just referenced Excel and so forth, but could you mention a little bit more about your preferred data analysis software that you're using?
Can you repeat that?
In your class. Yeah, our question is, are you using a data analysis software in your class?
Oh, that's an excellent question. I expose them to SPSS. When you look at the dynamics, there's the SAS group, and there's the R group, and then there's the SPSS group, and other ones. I think there's Minitab and all sorts of other ways out there. In the behavioral sciences, if you look at the data, SPSS is still the dominantly used one. But even if you look at the culture, among the technology groups, IBM bought SPSS, and then you have R, there tends to be more, at least the sense is, that there tends to be more of a culture of synergies among them than there are competition. And not that there isn't competition, but I think they're starting to see that it's probably better that we try to work together to see how these, when brought together, are more capable than alone. Like, for example, if you go onto SPSS's site, IBM SPSS, they actually have a whole web page dedicated to all the things that you can do if you use SPSS and R together. And so it's not a matter of this is why we're better and don't buy that, or, well, buy it, it's free. But the idea being that, instead of looking at it as a competition, it tends to be synergistic. I teach them SPSS. SPSS is what I used as a graduate student. It's what I use now as a professor. It's what I used in my postdoc at Arizona State University. And it's the one that I see more often than not as being used by the behavioral scientists around me. So I feel that I have an obligation to introduce them to the most popular tool that's out there now. So I use SPSS. Not that there is any one correct answer to that. And then I also try to expose them to Excel, and a lot of Excel is simply using that as my instructional template. So instead of using the chalkboard or smartboard or PowerPoints, I just open up an Excel spreadsheet, and typically with preset data, it always works well to come prepared with a data set. I can use that, and for example, I can have many columns of data, then I'll hover over it with the big hover over a set of cells, and then grab it with a hand and just move it over to different sets of data, and they can see different types of skewness. They can look at different types of variability in the data, and in a statistics class, I'll use it to show or illustrate sampling distributions and all of that. So I find it to be highly effective. Not necessarily, they don't ever get an Excel test. I don't test them on it of a formula versus a function or anything like that. But I feel like it's very valuable to them, and that's generally the feedback. They feel it's very valuable that they were able to see me manipulate data in an Excel spreadsheet, where that's most likely where a researcher is going to store all their data, and then they'll just copy and paste it over to whatever statistical tool they use to analyze. So those are the two that I predominantly incorporate, and a lot of it is to just expose them to that, if for no other reason, to expose it to them, to let them see, at least feel comfortable enough that they've seen it, and then going forward, that can give them a little bit more confidence going into a research lab or trying to get that added research experience that gets them ready to be competitive for graduate schools.
Well, great. I think this touches on one of our other, we started kind of talking about this already, but we had a question. How do you suggest dealing with students who lack confidence in their stats abilities coming into the class?
Who lack confidence?
Yes. Mm-hmm.
Okay. One of the ways that I do that is I typically will come out front and I will say, look, statistics in a math department is math. Statistics in a behavioral sciences and psychology, sociology, education, and almost all of the behavioral sciences, it's not math, it's how we make our decisions. So what I'm going to do is teach you a rationale of how we go about making the final decision about whether or not what we observed is what we think it is. And that's always been the way. I will tell you that from my experience, I have no successful formula how to break down those walls entirely. Students get very, very stressed. I structure my classroom to be able to provide so many levels of support that I thing called a supplemental instruction leader, and they have programs like that across the country. It depends. Different universities have it, different universities don't. But I have a student who's literally paid by the university to do 2 reteach sessions every 2 weeks for my classes, and then provide an additional 2 hours of office hours for the students. And typically you pick your A student from a previous class who you know is strong, and then every Friday I meet with them and we talk about different struggles that are in the classroom. But the nice thing is it's built around anonymity. So students know that I'm not allowed to know who does or does not attend these sessions. And the thought being that, even though I don't consider myself an intimidating guy at all, it doesn't matter, I'm a doctor. So for some students, they might feel uncomfortable asking questions that they think will make them seem stupid to me or something, even though that's not fair, that they're still learning, but they have that perception. And so the nice thing is they'll go to the SI leader, because it's just a fellow classmate, and they know that that classmate's not allowed to tell me anyone who ever attends those. And so it's nice, it's anonymous, and in that way I can get feedback from him on where they're struggling most, where I should probably spend more time in the classroom next week, and then at the same time they have a bit of anonymity to be able to ask questions if they're a little bit intimidated to ask me. So I guess the support network around it is what I focused on, and then to try to break down the barriers and convince them that even though you see numbers in front of you and we're about to analyze it, it's not math. I have to make a decision, and this is the process that I'm going to use to do that.
Great. We have a lot of great questions coming in right now, and please, again, feel free to use that Q&A chat box on your screen to submit questions for Greg. We'll try to get through as many of these as possible. Here are some more interesting questions for you, Greg. Most real-life research questions require advanced statistical analysis techniques. How would you help students with beginning or limited stats knowledge and skills deal with this complexity?
That is an excellent point, and I ran into this when I was writing the statistics textbook. You know, you introduce the analysis for a one-sample t-test, and then good luck going out and finding someone who ran a study that was entirely based on a single one-sample t-test. It's an absolutely excellent point. One of the ways that I go about it is, two strategies that I use. One, I use simple hypotheses. For example, I found a nice simple study that the students perform better in afternoon classes than morning classes. Okay, that was a nice two-page paper, by the way, nice and simple read. I'm not saying that you're exposing them to the complex sciences, but then again, they're going to go to their advanced courses and learn about those. That's not our job. Our job is to elucidate to the processes that are in place in terms of establishing hypotheses, considering controls, whether or not variables are pre-existing. So I will work with very, very simple hypotheses. The other thing is, and this has been the fun part of being actively engaged in student research, we've done that ourselves in our research. And so what I love to do is to take the student research projects that we've published in peer-reviewed studies and use those as the examples. For example, one such study, I'm a health psychologist by trade, and a lot of what I focus on is really just behavioral health outcomes, the extent to which our behavior contributes to our own health. In one, we based a study off of a nice, fun, simple study off of Brian Wansink from Cornell, where he moved a bowl of popcorn in different places in a room and found that the closer he put the popcorn, the more people ate of it. And so we simply asked the question, does it matter what you put in the bowl? And think about it. Right now, this is a very simple conversation to have with a student. This is not overly complex. This is the thought process that went into a study that was published in a very strong journal, Appetite. In fact, this was one of the studies that was featured in the Wall Street Journal. They picked up on it, and I think a lot of the student research is so readily picked up by media because it's so easy to understand. You know, anyone knows that the more complex the study is, the more general media is going to go, I don't understand that. Next. But if they can understand it readily, and it's an easy thing to wrap your mind around, and they can see that their readership would find it easy to wrap their mind around, they'll write about it. And so what we did was we varied where a bowl of apples and carrots were in the room, and we found the exact same pattern. But that has important implications because it says that that you can actually enhance intake of healthier foods. You don't want to increase intake of popcorn, although the popcorn companies, you know, it's a healthy food without the butter. It would be a healthy food. It would be a whole grain, 100% whole grain. Just in case, you know, someone from a popcorn company is listening in on this conversation saying, how dare he? But the idea being that we did that simple study, and then we published a second study in the journal Environment and Behavior where we simply asked, well, what if there's a competition? What if there's other foods that they prefer more? So we had popcorn and a bowl of apples. They were both present in the room. So we look at one where it's just apples. That's their only option if they're going to eat. And then we have another where there's a bowl of apples and a bowl of popcorn. And we find, again, that if the apples are near, they eat more apples than popcorn. If the popcorn is near, they eat more popcorn than apples. So the rule seems to generally apply. Whatever's closer, they eat more of. Now, of course, we haven't tried the, cabbage or anything. I don't know if there's just foods that they absolutely won't eat, period. But in any case, they're simple, fun studies, and they're easy to explain. You can talk about the general research design. These are no more, yes, the analysis is going to include a higher levels of covariates. But for the class, you can introduce them without the covariates. You can talk about a simple one-way ANOVA or the two independent sample t-test. You can talk about those general designs and structure and introduce them in ways that I think are digestible for the students in that class. And that's what I do. I've been blessed and lucky to be able to work with students on so much research. It's so much fun, and we ask fun questions, although I'm extremely biased when I answer that. And by doing so, we have a lot of really cool examples now to give in class and to talk about. One was rate of eating, fast or slow, and all the levels of control that went into that. That I can talk about in methods, and it's a lot of fun. So I always go with simple design and studies that ask very easy, digestible questions. And I think you'd be amazed as you really go through and peruse through and I'm sorry I just used perused in a sentence, but as you peruse through the research literature, there's a lot of really simple, clever questions that are asked that I think students can wrap their minds around. And that's how I get around that, because your point is perfect. You're right. For the majority of research findings that are going to make it through a peer review, the analysis, the level of methodology required is complex.
Greg, do you have your students in a computer lab and working in the computer when you teach methods? That's another one of our questions.
That's an excellent question. Yes, we do have them in a computer lab. We just added it, though. For the first about 4 or 5 years that I taught it at the university I'm at now, we did not have them in computer labs, and it was frustrating, and it was a struggle. So that's when I started this incidental learning type of process where I would at least expose them to it. And then I would give them, and even in a methods class, but only because it follows statistics. So I know that they've already taken statistics. I would assign little SPSS exercises for them, where I would give them research examples, and then they would look at and analyze the data and make decisions about it. I would set up the context, but they would have to think through how to analyze it. And there were, again, lots of levels of support. I don't want them just to feel like I'm judging them. I want them to be able to learn from the process, not just submit it to me so I can mark them wrong on everything and say, figure it out. It was a very interactive process, and that's the way I approached it. I said, look, let's take advantage of this and look at me as a collaborator on this. And I think it eased the stress of the students. They felt like they were being asked to use this technology. They were being asked to do it on their own time, but in a way that was encouraging them to learn it with my support, as opposed to just something else you have to do, go do it, if that makes sense. So yeah, right now we do, and it's just so wonderful, to be honest. And if you don't, I think that if you use the technology and have them do it on their own time and structure it in a way where they have a bit more support in doing it, that's going to work much more effectively. But it also depends on your class size as well. At some point, the class size is going to be way too big for you to handle all that. And we max out at about 30, 35 students, I think, in the class, and that's manageable for me.
Well, going back to sort of the theme of today and finding common ground, here's another interesting question that came across, and we probably have time to answer this and maybe one last one. But given that at this person's university, the methods and stats courses are typically offered as different courses taught by different instructors. So this person is interested in your recommendation. Should stats and methods courses be combined to facilitate bridging the two areas?
Oh, that's a great question.
That's a big question, right?
Oh my goodness. Whatever my response to that is completely my opinion. I like the idea of combining them, but that's with a caveat, because I've taught it both ways, and what I noted is the general structure of a combined class is still one of those, okay, this week bring your methods book, this week bring your stats book. And so, yes, it's not just all methods followed by all stats. They integrate it, but for a lot of the combined courses, it's still a little more disjointed than it probably should be, in that you'll have a methods for maybe 2 weeks and then a little bit of statistics and analysis, and then you'll go back to methods and design, and then you'll go back to analysis. That is not absolutely true across the board, but you see that in many combined courses. In many ways, I think that the best solution is to think about ways to simply retool the way that you deliver the content. The two examples given there, where stats and methods is literally in the same moment in time being introduced. And I find that those are the most effective places where students have their aha moments and say, okay, I get that. get that. And then there's still a lot of professional development left to put the rest of the pieces together, and that's half the joy of being a professor, in my opinion, and having this life, which in my opinion is joyous because it's a constant battle to professionally develop for a career. I'm always looking to improve, and that seems to be the spirit of most of my colleagues, and it's enjoyable. It really is. When you look at the bigger picture, though, I think a lot of the combined classes aren't much different than the separated classes, except that they stagger methods and stats. There's no doubt, I think, that there is strength in merging the two. The challenge, I think, really is always going to be, if I were to put my administrative hat on, staffing it. It was really neat to see how many people in the audience here feel that both stats and methods are a strength, but I think that as a general rule, you tend to see faculty who fall into this camp where they feel really, really strong on methods, or they feel really, really strong on statistics, but they don't want the two to, they wouldn't want to do both of those courses, so to speak. I happen to teach them both. Of course, I write books on them both. So part of that professional development was me thinking of myself as a student, saying, well, man, I didn't understand how to put this together. I didn't feel like I was getting the whole story. And I want to figure that out. And so I decided that my major professional development very early in my career, before my PhD, was to study statistics and research methods together and start to see if there are ways that there are synergies among them that can make it easier for me to understand the content. And when I realized it made it easier for me to understand the content, I started testing that out on my students. So I still think in many ways it's a matter of reevaluating how you deliver the content as opposed to teaching a stats methods combo course, which has huge advantages. I think largely for many universities the challenge would be staffing, and I know many universities actually have multiple faculty contribute to that. I have one in Boston. I know I have colleagues where they actually have 2 instructors, 2 professors who are assigned to that class, and they teach cohesively together because they each bring individual expertise to the table, and it's kind of neat. I've never seen it done, but it seems like a neat idea.
That was a great response to what is definitely a complex question. So thank you, Greg. I'm sorry to say that that is about all the time we have for today. And just want to say a sincere thank you to everybody for joining us, and a special thank you to Dr. Greg Privitera, who is just such a celebrated author here at SAGE. And you can see on the screen here, you can request complimentary copies if you're an instructor at our website, sagepub.com, or use the code Privitera20 for a 20% discount if you're a practitioner who wants to make a purchase. Greg's titles are up here on the slide. He does have his research methods for the behavioral sciences award-winning text coming out in a 2nd edition this January. Someone asked if they were teaching primarily a methods course, what would be a good resource? This would be it. Greg also has the Essential Stats book, the full stats book, and then a Getting into Graduate School text as well. So we hope that you will please be on the lookout for an email from us that includes a link to view the entire webinar and slides, as well as, again, as we promised, Greg will answer questions that we weren't able to get to today. And please stay connected with us on our blog, Sage Connection, for information about upcoming webinars. I just want to say once again, thank you to all of you for attending. And Greg, thank you so much. What a terrific presentation.
Thank you, everyone. Thank you. It was a pleasure.
Thank you.